Okay, greetings everyone. Today we are going to touch on module 1. Okay, it deals with heating and expansion of gases. Okay, heating and expansion of gases. Make sure you write that somewhere down. Why? Because there's three things to factor into consideration here. One, it's heating as well as expansion of what? Of gases. Okay, so it's the heating and the expansion of gases, right? So there's three elements that are taken into consideration. Okay, right. Now let me just zoom in. Okay, right. Here we will see the learning outcomes. Okay, learning outcomes. Now what I normally like to do is I normally like to write stuff down. Why? Because by writing stuff down, it actually or allegedly improve your chances of memorizing and better understanding the stuff that you wrote down. Okay, so let's do that. Okay, right. So learning outcomes, right? So when we talk about learning outcomes, there is 5 different type of outcomes. Okay, 5, right? So let's write them down. This is 1. Okay, then there's also 2. Now these 2, they deal with describing. Simply meaning both 1 and 2 is where you have to describe. Okay, and then you have 3, you have 4, and then you have 5, and they deal with what we call calculating. Right? So if we talk about 1 and 2, it's stuff that you normally have to describe. If we talk about 3, 4, and 5 of the outcomes, they deal with what we call calculating. Okay, so now what is it that you have to describe? Okay, one of the outcomes that you should be able to describe is what we refer to as laws of thermodynamics, right? Laws of thermodynamics. Another thing that you should be able to describe is gas processes. Okay, gas processes. Okay, right, or gas processes, depending on how you enunciate it. Okay, and just now let's deal with the calculating aspect. What should you be able to calculate? You should be able to calculate heat transfer on a gas. Heat transferred on a gas. Okay, right. Also, you should be able to calculate work done on or to a gas. Work done on or to a gas. The top one says heat transferred on a gas. Okay, heat transferred on a gas, work done on or to a gas, and then also you should be able to calculate what is known as the internal energy of a gas. Now when I talk about on, of, on, or to, those are what I will refer to as qualifiers. Okay, this is not a literature class, so don't be too concerned about the specifics, but yeah, this is just to help us better in dissecting the study material at hand. So yeah, okay, right? So there's our learning outcomes. Okay, right? So now we are going to deal with number 1. Number 1, it talks about the introduction. The 1.1, it says, since temperature and air pressure, okay, since temperature, okay, and air pressure vary, okay, so you have temperature and then you have air pressure. They vary from place to place. Now that should be common sense. Okay, vary from place to place. It is necessary. It is. Let me just do this. All right. since temperature and air pressure vary from place to place, okay, it is necessary with a standard reference condition to compare testing and documentation of chemical and physical processes. Okay, so you have two types of processes. Now you have chemical as well as physical processes. Okay, and then there's what we refer to as standard reference conditions that we now use to compare testing and documentation. So simply meaning, what is it? You have this thing called temperature, and then you have this thing called air pressure, and then they vary. Okay, so we are going to write that down. We are going to make notes. We are going to make notes. Okay, right, let me just do that. All right, so according to the introduction, according to the introduction, you have this thing called temperature. Okay, and then you also have this thing called air pressure. For now, I'm just going to write P and then qualify it by saying air. Okay, so you have both of these things, meaning and. Okay, now here's what's happening there. Since temperature and air pressure vary just simply means that they change. This is how we are going to denote change. Okay, right, so there's a change in air pressure, there's a change in temperature. Okay, right, and this happens from place to place. Simply meaning, if we have A, we have B, we have C, and we have D, at A, B, C, and D, it's going to be different. Simply meaning, that's what we mean when we talk about vary. It changes. It's not the same thing. Okay, right? It's going to vary from place to place, and it is necessary, okay, with a standard reference condition. It is necessary with a standard reference. So over here, we'll say STD, meaning standard, okay, reference condition. Okay, so when we talk about a standard reference condition, essentially speaking, what we are trying to do is we are trying to compare testing. We are trying to compare two things. We are trying to compare testing as well as documentation. Okay, of what? Of two things. Of chemical as well as physical processes. That is essentially the objective here. So we have standard referencing conditions, okay, and then that is used for testing and documentation of chemical and physical processes. Okay, so that is basically the introduction. Now, okay, right, let's continue. Just as a side note, for now we are going to put here a side note, meaning this is critical to know moving forward. Right, what is the side note? The side note, it's basically thermodynamics. Thermodynamics, okay, it is a relation between, simply meaning it is a relation between heat and work. And the properties of a gas. Okay, right, so when we are talking now about thermodynamics, essentially we are dealing about we are talking about the relation between heat, work. Now when I say heat, that's one thing, work, that's another thing, and then the properties of a gas. Okay, now when we say properties of a gas, let's quickly delve into properties of a gas. Now properties of a gas, I'm going to write here properties of a gas. We have to qualify properties of a gas, simply meaning in some way when we are referring to properties of a gas, now we will actually have to describe what exactly it is that we are talking about, okay, or what does it include. Properties of a gas, now it includes mass, okay, as well as something known as specific specific heat capacity. Specific heat capacity. Okay, so for now, when we are referring to the properties of a gas, we are referring to the mass of the gas as well as the specific heat capacity of this gas. Okay, now obviously there are more properties, but for now we will limit ourselves to these two properties of a gas. Okay, so just to wrap this up, thermodynamics, when we talk about thermodynamics now, fundamentally we are talking about the relation between three things. Okay, what are those three things? It's heat, it's work, as well as the properties of a gas. Properties of a gas. Now, when we talk about properties of a gas, what are we referring to? We are referring to the mass of the gas, as well as the specific heat capacity of that gas. So for now, we are going to conclude over here.